Welcome to my video for Module 5 on estimating the population variance and standard deviation. So the first problem, I'm going to be estimating the variance, which is sigma squared, which is that formula. And the second problem, I'll be estimating the standard deviation, which uses this formula, pretty much the same thing. The first one is sigma squared, so obviously it's without the square roots. And then you take the square root of all three of them, and you get that formula. So these two formulas are basically this one. This is the main formula, and then this is the square root of it that gives you the standard deviation, which is sigma. Now we're going to use obviously S here, as you can see. We're going to use S sample standard deviation, S squared sample variance to calculate the actual variance. That's been the story throughout the entire chapter. We've used the sample information with these formulas to be able to estimate the actual population character that we're talking about, in this case the population variance. Now here we have a problem. They've given us a data set. It says given the sample size and the sample variance above, that's just right here. So it says your sample size is 38 and your sample variance, which is S squared, is 25.4. It says find a 95% confidence interval for the variance. Well, right there, find a 95% confidence interval for the variance tells you that you have to use this formula here. Okay, well, let's type what we got. What's n? My n is 38. N minus 1, I need that for the formula, so I need to create it. So in n minus 1, S squared is 25.4. I don't need to calculate it, it's given. Chi-square right, chi-square left. Now, chi-square right, you've seen it on my lecture video through the PowerPoint. So you will type chi-squared, chi-square, and you have to obviously use inverse. All the commands in this module use inverse. And you have to use the one that says right tail. So because you're finding chi-square right, so you use chi-square dot inverse dot right. Basically, that wants you to write the area in the right. Now, the number that goes here now will be 1 minus the confidence level divided by 2. 1 minus the confidence level divided by 2. Now, before I type this, I just wanted to show you the command. I'm going to delete this and actually figure out what's the number I need to type in here now. So I'm going to delete that. I'm going to come here somewhere on the side, and I'm going to make it yellow. And I'm going to figure out exactly the probability I need to type into my command when I'm ready to type it. So 95%, so I said, what do? You do equals 1 minus 0.95, enter, so you get that. And then you take that and you divide it by 2. So it's two operations. You subtract 95% from 1. It's a little different than the way you found the t and the z values. So there's just 3 of them. You have to learn how to do each one. I've taught you how to do the z. I've taught you how to do the t. Now this is how you do it for the population variance critical value known as chi-squared. So you do 1 minus the given confidence level. So you do 1 minus 95%, which gives you 5%, 0.05, and then you divide that by 2. And that's what you use in the command. So let's type the command chi-square, again, inverse right tail. It says put in the probability, so that's the probability, comma, and the degrees of freedom is always n minus 1, and here there's only one n, so 38 minus 1 is 37. So that's how you find the chi-square right value. Now chi-square left value is the same thing, but without the right tail. So you write equal to chi-square inverse without the right tail, and you just put the probability and you use the same probability, comma, and the same degrees of freedom, 37. The only difference between the commands is one uses right tail, the other one doesn't, obviously, because it's the left tail. And there is the chi-square left. So chi-square right, I copy them here now back into where I type my input information given from the exercise. So my chi-square right equals to, I could just click on it and capture it. My chi-square left equals this number here. Alright, so now I'm ready to actually use this formula and type it in where I have designated as the left hand side. Right hand side, lower confidence limit, upper confidence limit. So for my lower confidence limit will be equals to n minus 1, which is 37, times s squared, which is 25.4, and it's already s squared, so I don't need to square it, divide by chi square right, which is that. And that's the left-hand side of the lower confidence limit. The right-hand side of the upper confidence limit will be again n minus 1 times s squared, divide by chi square left. So I divide by chi square left. And there's my right-hand side of the upper class limit. So that's my confidence intervals. My variance is somewhere between 17 and 43. All right, let's look at the next one. The next one is the same type of a problem, but it's asking you for a 98% confidence interval, and it's asking you to do it for the standard deviation and not variance, which means I need to put square roots around the left-hand side and right-hand side part of the formula from above, and I don't write sigma squared, I write sigma. So it's pretty much the same thing. It tells me at a supermarket how many lines are there for 7 randomly selected customers, and so 7, so n is 7. So 7 randomly selected customers, which means n minus 1 is 7 minus 1, which is 6. It says for the 7 randomly selected customers, the variation was 2.98, so s squared is 2.98. Chi square left, chi square right. We need to calculate it again, but this time for 98%. So since I've already done it for the above part, I'll just do it here. So what do? We do equals 1 minus the confidence level, which is 98%, 0.98. And then, it changes the numbers here. Whatever, doesn't matter. And then you could rewind the video and see what it was. And then, so we do 1 minus the confidence level, which for example 9, it's 98%. And then you take that and you divide it by 2. And that's what you use in the command. So we have it here. Why not? Let's just use it. So this one will just be K9, correct. But we have to adjust the degrees of freedom because for our new problem, n is 7. So degrees of freedom will be 6. So instead of 37, I have to type 6. So that's the new chi square right. Oh, it affects this one too. It's okay, don't worry about it. Yeah, because I directly linked it to this example, so it's going to use the same and change the answers here. So don't panic. This, what I'm doing, precisely belongs to example 9. If you rewind the video, you'll see the exact numbers that belong to example previous one, example, let's say 8. All right, so anyways, let's just compute them anyhow for this new number. So it's K9 and 6 degrees of freedom. This is again K9, and you have to adjust. It's 6 degrees of freedom. And now here my chi square right would be that one, and my chi square left will be that one. And now I can use this formula to figure out my left-hand side and right-hand side. My left-hand side will be equal to, since you start with a square root, you'll start with a square root. It will be n minus 1, which is 6, times s squared, divide by chi square right. My chi square right 16 point whatever. And the other side will be the square root of, open parentheses, again n minus 1, times s squared, which is 2.98, divide by, this time chi square left, which is that one. And there it is. My standard deviation is anywhere between 1 to 5. Thank you.